So good evening. So today what we will be learning is application of Gauss law. So first of all, what is Gauss law? So let me write the mathematical form of Gauss law. So Gauss law states the electric flux, which is E dot ds, performed over a loop, performed over a closed surface S, is equal to Q enclosed divided by epsilon naught. So first we have to learn what it means, what this statement means. So the left hand side means electric flux. So left hand side is nothing but electric flux. Right hand side is 1 by epsilon naught times Q enclosed. Now what is electric flux? Electric flux is nothing but dot product between electric field and area vector ds. And what is S here? S is any hypothetical closed surface. So for example, let me draw a figure here. For example, this is a closed surface. I will call this S. This is the closed surface, and within this closed surface, if this closed surface encloses any charge, that is nothing but Q enclosed. For example, if there is a charge here Q1 let's say, and let's say there is a charge Q2, then this surface encloses charge Q2, not Q1. So therefore, Gauss law will be applicable for Q2 only and not for Q1. Why? Because this surface does not enclose Q1 but encloses Q2. So we can apply Gauss law only for those charges which has been enclosed by a closed surface called as, you usually call this as Gaussian surface. So what is this? This is called as Gaussian surface. So based on this, in the exam in the JEE you can get a question. So for example, there is a closed surface. I call this S again, and inside that closed surface there is a dipole, and outside that closed surface there is another dipole. So what is a dipole? Dipole actually consists of two charges, two similar charges but with opposite nature. So Q and minus Q, separated by some distance. So there is a dipole outside that surface, and there is another dipole inside the surface, Q1 and minus Q1. Now we have to apply Gauss law to this surface, and what we will get? We will get left hand side will be E dot ds over the closed surface S, which will be equal to, at this enclosed charges is nothing but Q1 minus Q1 divided by epsilon. Why minus? Because this is Q1 and this is minus Q1. So total charge enclosed is Q1 minus Q1, which is 0. So the answer will be 0. You don't have to mind anything about this one because anyway it is outside. So what is relevant is the charges enclosed within this surface S. So hope this is clear. Now we can see a derivation. If you want to calculate the electric field produced by a point charge, electric field by a point charge due to a spherical shell or a spherical conductor. How to do this? So what is the question? Question says there is a spherical shell. Shell means a thin, thickness will be very thin. So this is a spherical shell. There is nothing inside. There is charge contained in this thickness. I will call that charge as Q. So what we are asked? We are asked to find the electric field at some point here. Say this is point B. So what we have to do? So what we have to do, at this point we have to draw a sphere. Now this dotted line, this sphere will be my surface S, which is nothing but the Gaussian surface. Then I have to apply Gauss law, which is this one, to this surface S. So what does left hand side becomes? It is E dot ds over S, and what is the charge enclosed within this surface? Which is Q. So I just write Q by epsilon. Okay. So now you can see that electric field is a vector, ds is a vector. So there is a charge Q here. So if I draw electric field direction, it will be like this. This is the direction of electric field. Now what about ds? ds is nothing but the area vector. So area vector will always be perpendicular to the surface. For example, S is the surface. If I consider a small area here, area vector will also be along this direction. as you can see, angle between E and ds is 0. So if I perform the dot product, what I will get? Double integral over s E ds cos of 0. And as we know, cos 0 is nothing but 1. So what I can write is E ds equal to q by epsilon. Now as you can see, E is constant everywhere on the surface. Electric field, the magnitude of electric field is constant everywhere on the surface. Why? Because first of all it is symmetrical, secondly the distance is same. So what we can do, we can take electric field E outside the integration. So we will get E double integral S ds is equal to q by epsilon. Now what is double integral of ds? So integration is nothing but summation of continuous variables. So since this is the ds, if I sum all the ds's, I get the surface area of the sphere. So this is nothing but E. Surface area of the sphere is 4 pi r square, where small r is the radius of the Gaussian surface. So this is nothing but 4 pi r square, which will be equal to q by epsilon. Now from this we can find out electric field. Electric field, I'll just send this over there. So E is equal to q by 4 pi r square into epsilon. Hope this is clear.